Hi students, I'll try in this educational video to technologically explain how to size a pipe based on the ASME calculation code, of course, as simply and as clearly as possible. Okay, let's go. Well, as a pipe sizing overview, I will differentiate the different piping components that can be sized. We have obviously the straight pipe. We have also the curved segments of pipe, like pipe bands and elbows, and we have the miter bands. Okay, for the straight pipe, we have two cases. The case one is when the pipe is subjected to internal pressure, and in this case, the straight pipe is sized based on the ASME B31-304.1.2. And for the second case, the pipe is subjected to external pressure, and in this case, it's sized based on the ASME Section 8, Division 1, UG-28 through UG-30 and UG-29. For the case of curved segments, pipe bands, and elbows, the sizing will be based on the ASME B31-304.2.1 and .2, based on the model that you see now on the left of this slide. And for the miter band, the sizing will be based on the ASME B31-304.2.3 based on the model that you see now on the right of this slide. In this educational video, we will handle the case of the sizing of straight pipe and the case of curved segments of pipe. Well, now I will explain the general rules for the sizing of straight pipe. Based on this formula, which states that the minimum required thickness Tm should be equal to a certain pressure design thickness plus certain allowances, which are the corrosion and erosion allowances and the thread or groove depths. And this formula is extracted from ASME B31-304.1.1. And the pressure design thickness is obtained in two cases. The case one, of course, when the straight pipe is subjected to internal pressure, and the pressure design thickness in this case will be obtained by the formula that you see now on the left of this slide. P is the design gauge pressure, and it's equal to 1.1 times the working pressure. D is the pipe outer diameter. S is the allowable stress, and it's obtained based on ASME B31.3, table A-1 and -1M. And the weld joint quality factor E is obtained based on the ASME B31.3, table A-1A and -1B. And W is the weld joint strength reduction factor, and it's obtained based on the ASME B31.3, table 302.3.5, and the coefficient Y is obtained based on the ASME B31.3, table 304.1.1. And for the second case, when the straight pipe is subjected to external pressure, the thickness of the pipe is obtained using the same procedure as for the sizing of cylindrical shells and tubes based on the ASAB Section 8 Division 1 UG-28 through UG-30 and UG-29. Please pay attention here in this procedure when the outer diameter divided by the thickness, so du by t, is less than 10, the allowable stress S will be the lesser value of 1.5 times the stress value from the ASME B31.3, tables A-1 and A-1M, and 0.9 times the yield strength from ASME Section 2 Part D, Table Y-1. It's to note here that I will try in next educational video to apply a tutorial stating how to apply these formula and how to determine the different value of the different quantities based on the ASME B31.3, like the allowable stress, the well-joined quality factor, the well-joined strength reduction factor, and the Y coefficient. Now I will explain the general rules for the sizing of pipe bands, and as you can see, always based on the same formula stating that the minimum required thickness of the pipe should be equal to a certain pressure design thickness plus a certain allowances. And in this case, the case of pipe bands, the pressure design thickness is determined based on the ASME B31-304.2.1, and based on this model, we can determine the pressure design thickness T based on the formula that you see on the right of this slide. And here the quantities P, D, S, E, W, and Y are the same as for the case of straight pipes. And the coefficient I is determined for the intrados using the formula that you see now in this slide. And there are another formula for the extrados. And R1 here refers to the mean radius of the pipe band. And you can notice here that for pipe bands, the thickness will differ from intrados to extrados. And it's to note here that I will apply in the next educational video, I will apply a tutorial indicating how to use these formula and how to size the pipe band. Okay, this educational video takes end. Please mention all your remarks and suggestions in the comments. Thank you very much for your attention.